Okay, so what we're going to do today is we are going to wrap up 8.2.3. So before break, we did this front side, okay, and where we found out that, all right, so if we're going to graph a quadratic in standard form, we can do that by first plotting the y-intercept and then by factoring to help us find the two x-intercepts. And then we've got enough information we can make our graph. But we found out that sometimes our quadratic doesn't factor. So if it doesn't factor, how can we still find the x-intercepts? So we saw that just because it didn't factor doesn't mean it doesn't necessarily not touch the x-axis. It just might touch the x-axis at a place that would be difficult to find through factoring. So you kind of ended the lesson with trying to find, using technology, where the x-intercepts are for these different functions. So in the first one, you found that it was at approximately these two decimal amounts. The second one, it actually just touched at one spot. The third one, again, it was at an approximate decimal amount. And then the last one, we found out that there actually wasn't any x-intercepts, so the parabola did not cross the x-axis, which can also happen. Okay, so what you need is this second paper. So hopefully you printed it out. If you didn't have it, if you don't have a printer at home, you can just use a sheet of, just regular graph paper would be fine. All right, so 79 says the following functions are also quadratic functions. This just looks like a different form than what we've seen. It doesn't really look like it's in factored form, nor does it look like it's in standard form. So factored form, it would kind of look like y equals, and then it would have two things that are multiplied together. Okay, if it's in standard form, it would look like something times x squared plus something times x plus some number, so that ax squared plus bx plus c, and it doesn't look like it's in that form either. So this new format that we're going to be looking at is actually called vertex form, and we're going to kind of see why. Okay, so but first of all, the first thing I want you to do is to prove that that these are both quadratic by rewriting them in standard form. So I want you to convert that one to standard form. Okay, so let's convert this one to standard form. I'm just going to go ahead and write on the whiteboard just because it gives me a little bit more space to work with. Okay, so if I'm going to change this to standard form, I want to get it to look like something times x squared plus something times x plus something. So I'm going to go ahead and I'm going to square that x minus 2. So I'm going to go ahead and just multiply x minus 2 times x minus 2. That's what it means when you square something. Remember, we cannot apply that rule where we just square both of those things because of that subtraction sign. So I need a generic rectangle. So I'm going to get x squared minus 2x minus 2x and then plus 4. So this is y is equal to 3 times x squared minus 4x plus 4 minus 5. All right, then I'm going to go ahead and distribute by 3. So y is equal to 3x squared minus 12x plus 12 minus 5. And then I'm going to keep simplifying. This is y equals 3x squared, okay, minus 12x plus 7. Okay, so if we're going to convert this first one from this form to standard form to show that it is a quadratic, just another format, that's how we could do that. Okay, and if we look at this, do you think there's a way I could tell that these are actually equivalent to each other? So here's this first one graphed, the y equals 3 times x minus 2 squared minus 5. And then I'm going to graph 3x squared minus 12x plus 7. I'm going to turn that graph on. What do you think should happen? Okay, did you notice that it just plotted right on top of the other? So they are actually equivalent to each other. All right, so I'm going to ask you to do that same thing with number 2. Okay, so we'll go ahead and I want you to convert that one. Should I keep plotting little dots on the screen? But I want you to go ahead and take that one and convert it to standard form. Okay, so we've got f of x, is equal to negative 2 times x plus 4 squared plus 3. And I'm going to try and convert it from this form to standard form. So I'm going to make it look like something times x squared plus some x number plus a constant term. Okay. All right, so I'm going to square this. So I'm going to go ahead and I'm just going to make a little generic rectangle here. And I'm going to do x4, x squared, 4x, 16. So I get f of x equals negative 2 times x squared plus 8x plus 16 plus 3. Now I'm going to distribute the negative 2. I'm going to get negative 2x squared minus 16x minus 32 plus 3. Then I'm going to combine my negative 32 and my 3. Okay, and this gives me negative 29. Okay, so, and again, I'm going to go back to Desmos, just got a little proof here. Okay, so I'm going to go turn this one off. Okay, so this was my original. My f of x equals negative 2 times x plus 4 squared plus 3. And this is in standard form. So negative 2x squared minus 16x minus 29. So what do you think is going to happen when I turn that one on? If I did it correctly, it should be the same graph, which it is. Okay? All right. Okay, so we did that. We verified that they were both quadratic by changing them to standard form. Okay, so we converted that first one to standard form and got that it was equivalent to y equals 3x squared minus 12x plus 7. And our second one, we converted it to standard form, got that it was equal to f of x equals negative 2x squared minus 16x minus 29. Okay. All right. Okay, so that was kind of A, and we verified it by checking on Desmos. All right, so it says use the graph and table on your graphing calculator to find the vertex of each function. Okay, so let's go back to that first function, which was this one in either form. Okay, we're going to look closely at the vertex. Okay, so I'm just going to click right here on Desmos. Here's the vertex. Okay, what point is that? So the vertex of this one is 2, negative 5. 2, negative 5. So let's compare that with our equation. So the vertex of this one right here is 2, negative 5. What's special about when I make x be 2? Okay, so when I make x be 2, 2 minus 2 is 0. 0 squared is still 0, times 3 is still 0, and I'm going to end up with negative 5. All right. Let's look at this one. What do we think the vertex of this one is going to be? Well, what x value would make this 0, and then what would I get? Okay, so let's go ahead and take a look at that. I'm going to turn this one on. Okay, where is the vertex? It's right here at negative 4, 3. Okay, so let's look at that. The vertex of this one is negative 4, 3. So what's the significance of negative 4? When I make x be negative 4, negative 4 plus 4 is 0. 0 squared is still 0. Times negative 2, that's still 0. And I get 3 as my output. Okay? So knowing that, I don't know why I've got these little dots here. Sorry. Oop. Okay. All right. So knowing that, what do you think the vertex of this is going to be? Y equals 1/2 times x plus 3 squared plus 2. Okay. So what value of x would give a minimum point? All right, my conjecture it's going to be negative 3, 2. Now, how did I come up with that? What x value is going to turn this all into a 0? Negative 3. okay? And then if this turns all into a 0, what's the y value going to be? It's going to be 2, okay? It's going to be a 2. So if x is anything either more than -3 or less than -3, I'm going to get some value that's going to turn out to be a positive and is going to be more than 2. So this has got to be the minimum point on my graph. Okay, this is called vertex form. Okay, so vertex form is super helpful. Where are these other dots here? Because vertex form will allow you to not only graph the vertex from the equation, but it's actually also super easy to find the x-intercepts when it's in vertex form. Okay, so we're going to try and graph this quadratic, okay, using that vertex form. Try to zoom in a little bit. Okay, so the first thing we're going to do is think about the vertex. Okay, what special value could I put in for x? Well, if I make x be -1, -1 plus 1 is going to be 0, and I'm going to end up with -9. So I'm going to plot my vertex at -1, -9. So I'm going to think about what x value will make all this squared part 0, and then my y value will be what's left. Okay, that's my vertex. So at -1, -9. Okay, what else do I want? I want my y-intercept. Now remember, the y-intercept happens when x is 0. So now I'm going to plug 0 in for x. So what's 0 plus 1 squared? I'm going to try and find y when x is 0, minus 9. So 0 plus 1 is 1 squared minus 9. 1 minus 9, y is going to be -8. Okay, so I'm going to go ahead and plot my y-intercepts. So when x is 0, y is -8. Okay, so I know that my parabola is going to probably start heading up from here, okay? So by with this being my vertex, so by symmetry, I could actually probably plot this point too. So it's going to be heading up. So now I need to find where it touches the x-axis. Now you might think, okay, well, we have to get it in factored form, and I could change this to standard form and see if it factors, but actually there's a really easy way to find the x-intercepts when it's in vertex form, okay? So you're gonna like this. So the x-intercepts happen when y is 0. So I'm gonna write 0 is equal to x plus 1 squared minus 9. Now you might be tempted to want to square that and then subtract the 9 and then change it. But remember, that's going to give me an x squared and an x that when I try and balance, I'm going to get stuck with, okay? So here is what we could do instead, okay? So I'm going to add 9 to both sides. And now I get 9 is equal to x plus 1 squared. Okay, and here's where it gets kind of simple then. Let me just cover my finger here. What number squared is equal to 9? Is there another number besides 3 that squared is equal to 9? Okay, so either x plus 1 could equal 3 or x plus 1 could equal -3. Well, what would x have to be for this to be true? Wouldn't x have to equal 2? How about to make this true? Wouldn't x have to equal -4? All right, so I'm going to, when x is 2, that's going to make this whole thing 0. And when x is -4, it's going to also become 0. And then voila, I've got my parabola with my x-intercepts and my y-intercept and my vertex, okay? All right, so here is another graph or equation that's in vertex form. So when you see it in this form, the very easy point to find is, first is to find is the vertex. So what x value would make this whole thing go away? Did you think -2? If I make x be -2 and this all goes away, what's y going to equal? Did you say -3? So I'm going to plot -2, -3. That's my vertex. Okay. Now I'm going to find my y-intercept. The y-intercept happens when x is 0. So I'm going to replace x with 0. Did you get 1? So I'm going to plot the point 0, 1. Okay, now by symmetry, I could probably also plot this point here. So can you tell that it's going to have to cross the x-axis? All right, so remember the x-intercept happens when y is 0. Okay, now you might be tempted to want to square that, but if you square it, you're going to get x squared plus 4x plus 4, then subtract 3, and then you're going to be stuck with your x and your x squared being separated. Okay, so which if you try and use the balancing method is not going to work out. So when it's in this, the square has been completed and it's in this form, the easiest way to solve is to just try and undo. So I'm going to add 3 to both sides. So I get 3 is equal to x plus 2 squared. All right, so what number squared is equal to 3? Okay, well, it's not 1. 1 times 1 is 1. It's not 2. 2 times 2 is 4. It's somewhere between 1 and 2. So it's actually the square root of 3. Okay, so either x plus 2 has to equal the square root of 3, or x plus 2 would have to equal negative of the square root of 3. Okay, so I'm just going to solve from here. I'm going to subtract 2. So I get x is equal to -2 plus the square root of 3. And I get x is equal to -2 minus the square root of 3. Now, since we want to plot this, we might want to go ahead and just figure out what the square root of 3 is. Okay, and add that to -2. So I'm going to go ahead and use my calculator to get an approximation for that. So I'm going to do -2 plus square root of 3. Okay, and that gives me about -0.27. And then I'm going to do -2 minus the square root of 3. Okay, and that gives me about -3.73. Okay, so I'm going to go here and I'm going to go to -0.27. So just right here. So -0.27, oops, 0 approximately for that point. And then I'm going to go to -3.73. Okay, so and then now I do have my x-intercepts also. Okay, this is pretty tough, so you might want to rewind the video and watch this a couple times so you can see how to, when it's in vertex form, figure out the x-intercepts, okay? All right, so now we've seen another form of an exponential, or sorry, not exponential, quadratic. The quadratic can be in factored form, it could be in standard form, or now we're seeing it could be in vertex form. We're going to spend some more time exploring that this week.